In this video, we're going to go over various ways to perform a sensitivity analysis in the Interactive Optimizer, as well as the cplex Optimization Studio. So for starters, I'm going to assume that we have some sort of linear program set up in the Optimization Studio. Now, if this is your first time running your program, then make sure to right-click on the configuration and select Run. Right? If you just click the Run button up at the top, it's not going to work the first time. So again, the first time you run an LP, you need to go ahead and select Run when you right-click on the configuration. After that, you can go ahead and just click the Run button up at the top, and you'll see you'll get your answers. In order to run a sensitivity analysis, the first thing that we're going to do is we're going to name each of the constraints. Here you can see me naming the constraints C1, C2, C3, and C4. Unfortunately, this process has to be done manually for these types of programs. As a next step, go ahead and copy and paste in the code that I've provided in the description below. This is the code that will actually perform the sensitivity analysis after we run the optimization. It's going to go through and print out reduce cost, dual variables or shadow prices, along with the slack variables for each of the constraints. The first piece of code I'm going to highlight is how do we go about displaying the dual variables or shadow prices corresponding to a constraint. So as you remember, we named each of our constraints C1, C2, C3, and C4. And as you can see here, if we just type in C1 dot, we have the option of filling in sort of some related properties to the constraint. They have to do with the name, the lower bound, the upper bound. And here we see an option where we can select the dual value of the constraint. Now this is the one that we're going to focus on for now. So go ahead and select it. Using a similar process, we can also access the slack variables associated with each constraint. Lastly, you can see we can access the reduce cost for each decision variable. Unfortunately, our sensitivity analysis doesn't go much further than that. We can't see how adjustments to the right-hand side or the objective values or coefficients of the basis variables affects our solution. Now, if you're wondering what's going on here, all that's happening is that cplex is running a little bit of code after it runs the linear program. So this little piece of code first basically checks if cplex found a solution. And it does this by the command or the line that says cplex.getCplexStatus. Now, if this function returns the value 1, then the solution was found. But if it doesn't return 1, then there was no feasible solution. So that's kind of what's going on here. And so here you can see the case that if we don't find a solution, then I'm going to print to the screen, solution not found. Now you can see when we solve the LP by running the configuration, we print out the slack variables, the dual variables, and the reduced costs for our variables. Now, one interesting thing that we can do is look at the reduced cost for our variable x2. This tells us how adjustments to our objective value might bring about a new set of non-basic variables. Focusing in on the reduced cost for x2, we can play around with what happens when we adjust the objective value coefficients for that variable. So here we see a reduced cost of -5. When we started, the coefficient for x2 and the objective value was 30. If we increase it to 34.9999, so just shy of 35, we see that we still get the same objective value and the same basic variables. So everything's still at x1 and x3. Now, if we just change our cost coefficient for x2 to be 35.001, so again, just above that change as indicated by the reduced cost, we're going to see we get structurally a very different solution. And there you have it. Now if you look, we see that x2 is 1.6, so it's entered into the basic variables, and x3 is 11.2, while x1 is 0. Additionally, we see a change. Well, we don't see a change in the objective value, or just a mild one, all right? But, even with a mild change in the objective value, we see a substantial change in the basic variables. Now, let's put back this 35 back to our original formulation, and we can sort of look at the shadow price of our constraints. Going back to the original formulation, when we solve and print out the dual variables and shadow prices, we see that the shadow price for our second constraint is 10. And again, if you recall, this tells us that if we increment the right-hand side value by 1, we should expect to see an increment in the objective value by 10. So doing that, we're going to change the right-hand side from 20 to 21. And sure enough, we'll see our objective value go from 280 to 290. And there you see it at 290. Unfortunately, the level of sensitivity analysis that you can perform in the cplex optimization studio is a bit limited. So what we're going to do is actually use another tool called the cplex interactive optimizer. Here we'll have a lot more options. Now, unfortunately, in order to do that sensitivity analysis, the procedure is a little bit clunky if you're starting from the optimization studio. Unfortunately, we just can't take this code and feed it into the interactive optimizer. We're actually going to have to export it. So in order to do that, what you want to do is right-click on the name of your project and then select New and Settings. Here, go ahead and name the settings file that you're going to create. In my case, I just named it Sen Analysis, but really you can pick whatever you'd like that makes sense. After you type in a name, click Finish, and a menu will pop up. Now, deep inside this menu at the very bottom, there's a folder called Language and then Run. And what we're going to do is within that Run options, we're going to request that it export a format of type LP. And this is more or less the standard LP file that you're used to sort of writing up in your homeworks. And what's going to happen is when we run the optimization studio, or when we ask for it to solve an LP, at the same time as solving it, it will generate an LP file that we can then load into the interactive optimizer. So after you go ahead and change the export format to LP, go ahead and close this tab out and say yes, or save the changes. And the last step is dragging in the settings file into the run configuration folder. At this point, we can go ahead and click the Run button. Now, when cplex solve the LP, it's actually going to generate a file associated with it. So here you can sort of see me. I'm going to go try to find the file. It's located within my home directory in Windows. And so it's a little bit kludgy to get here. But you'll see I'll have to go through the C drive. So just keep track of where your workspace is for cplex. Moving forward, I would actually suggest saving it within My Documents instead of your home folder. So when we scroll down, I finally get to the OPL folder where my workspace is saved. And here we see the sensitivity analysis. And now we see this file called configuration1.lp. At this point, we probably realize we should name our run configuration a better name. But that doesn't really matter too much. If you go ahead and open it, I'm going to go ahead and just use Notepad, which is standard text processing. You'll see that we have our linear program here, and it's exactly what we would expect a linear program to look like. We have our maximize, our objective function, subject to some constraints, C1, C2, C3, C4. And again, these were the ones that we named. And finally, we have an end statement that tells us that the LP is we've reached the end of the file. And so this is actually what we're going to use within the cplex interactive optimizer. As the next step, let's go ahead and load the cplex interactive optimizer from the start menu. So here I just started typing in cplex, and you'll see one of the options that pops up is cplex interactive. And there you have it. This is the cplex interactive optimizer. It's all a text-based program, so it doesn't have a nice, pretty GUI that you're used to necessarily interacting with through the optimization studio. Now, the first thing we're going to want to do is read in the LP file that we just produced. And we do that using the read command. And then we type in the path or the location of our LP file. Now, in this case, I didn't really like the name configuration1.lp. So you're going to see me rename it in a second or two. But you can see me typing in the path, which was within my home directory. So here I'm just renaming the file my first lp.lp. And at this point, when we press return, we've read in the optimization program into the interactive optimizer. Once we've read in the optimization LP, we can go ahead and type optimize, and it will solve the problem. You can actually see the objective value there. It's 2.8 times 10 to the second power. Now, what we're interested in is displaying the results from a sensitivity analysis. And in order to do this, what you're going to want to do is type in display. And from there, you'll be given an option of the different values that you can display. And here we're going to select sensitivity. After typing in sensitivity, press return, and we have the option of what sensitivity analysis we'd like to do. In this case, we're going to pull out the objective value. We're going to do a sensitivity analysis on that. And it's going to ask us for which variables. If we don't type anything in, then it's going to assume that we weren't interested in a sensitivity analysis. Now, an alternative way that you can access the sensitivity analysis is by typing in display sensitivity. So you don't have to go one step or one level at a time. And here what I'm going to do is I'm going to say, well, I know I want the objective value, and I actually want all the variables. And the way you indicate all variables in this program is to use the dash or minus sign. So I can just type in display, sensitivity, objective, and dash, and it's going to give me a sensitivity analysis for each of my decision variables. And sure enough, we see the reduced cost of -5 that we observed in the optimization studio. We also see the ranges for x1 and x3 on the upper limit and lower limit, for which we can vary the coefficients and still maintain the same basis. So right now, the current objective value or objective coefficient for x1 is 60. And I can vary that value anywhere between 56 and 80, and I'll still preserve my basic variables. if the objective value drops below 56 or above 81, then we can expect a change in our basic variables. The same idea holds true for x3. We see that its range of values goes from 15 to 22.5. Now we can look at other sensitivities. So we can type in right-hand side, and when it asks us which constraints we want, we could just, again, type in the dash button, and it will give us the right-hand side sensitivity analysis for constraints C1 through C4. And again, you see how you can adjust the right-hand side values for C1, C2, C3, and C4, and what those limits are. So in this particular case, our basis stays the same as long as our C1 constraint is greater than 24. So it can go from 24 all the way up to infinity. Meanwhile, our C2 constraint, if we want to maintain the same basic variables that are part of the optimal solution, it has to remain between 16 and 24. We can also display our solution by typing in display solution. If we type in basis and then V, it will give us our basis variables. Again, I typed in the dash to get them all. And x1, x3 is what we expected. We can also display our slack variables if we want, and even our dual variables. So here I took the little shortcut, so you see me doing display solution variables and then dash, right? So I didn't have to go through the whole menu. And again, here you see me displaying the slack variables, and these slacks correspond to the constraints, right? So S1 and S4. Again, we can display the reduced costs, which we had seen earlier. And it's finally worth noting that we can display the dual variables. So here we see the dual variables corresponding to C2 and C3 are 10 and 10. And again, this is what we've seen before. Our optimal dual variables were 0, 10, and 10 for Y1, Y2, and Y3. So with that, if you want to quit the interactive optimizer, you can type in quit, or you can just close it out. So that's how you perform a sensitivity analysis on the objective function right-hand side in cplex.